Alright, section 9.5, hypothesis test for one population mean when the standard deviation is unknown. Alright, so how are we going to develop a testing procedure when the population standard deviation is unknown? Well, think about what we had, okay? When the population standard deviation was known, we were able to use a z-score, a z-statistic, equals x bar minus mu over the standard deviation. And for our problem where we were looking at the sample trying to do the hypothesis testing, we actually did this a little differently because we were looking at a sample, if you remember. Alright, so now if that sample is greater than 30, okay, if the sample is greater than 30, well, it's the z-score, you can pretty much use it unrestricted, if you remember. So greater than 30 is a wonderful thing to have, but the only bad part about that is you don't get to control what how many samples you have a lot of times. A lot of times that's present for you. So suppose you have to use a sample and the population is unknown here. Well, we can take our population, and if we take the sample of the standard deviation, suppose we have a sample that's less than 30. The larger the sample, the more it's going to be like the population. So if it's less than 30, then we need to use something besides a z-score. More than 30, z-score. Less than 30, t-distribution. Okay, because we're using the standard deviation of the sample since the population standard deviation is unknown. Now when your sample starts getting large, remember, the larger the sample, the more it's going to be like the population. So if you get extremely large on your samples, you can use the z-score. But most of our samples are going to be on the smaller end, and so we'll need to use a t-score or a t-test, I should say. All right, so this will be our new test statistic for when we do our t-test here in just a minute. But before we do the t-test, we need to talk. And we need to have a serious talk. Because p-values for a t-test are not always as easy as p-values for a z-test. Okay, so you're going to solve, if you notice, these graphs look much like our normal distribution. The only difference in doing a t-test and doing a z-test is that our critical values or our p-values are going to be derived from table 4 instead of table 2. Table 2 was because we have a normal distribution. With a t-test, you don't necessarily have a normal distribution, so we have to use table 4 in the appendix to get the p-value and the critical values as opposed to table 2. Now that's really the only difference. If you notice, it looks very similar. But here's the problem. When we begin solving for these p-values, a lot of times table 4 is just not enough. We're going to only be able to estimate intervals a lot of times because here's why. A lot of times you need statistical software to be able to get an exact estimate on a p-value for a t-test. So, and I'll show you why here in just a moment. You're definitely going to need your book for this, so make sure that if you don't have it, pause the video and go get it, because we're going to need to refer to it quite often with this particular section. Alright, so